all students of class 8. Myself Grisha and I teach mathematics from class 8 to 10. Dear students, first of all, for the student of class 8, I am going to teach first chapter, that is rational number. In order to understand rational number, we are required to know some numbers, like for example natural numbers, integers and whole numbers. Let's see what is natural numbers. Natural numbers and whole numbers and then integers. Dear students, for natural numbers, all the counting numbers are called natural numbers, and a counting number starts from 1 and end to infinity. That's why we can write here for natural number 1, 2, 3 and so on up to infinity. Secondly, whole number. The range of whole number is slightly greater than that of natural number. It means that when 0 is included in the family of natural number, then the family becomes whole numbers. It means that whole number start from 0 and end to infinity. And the third number, that is integer. Integer is natural number and negative natural numbers with 0. This family is called integers. It means that family of natural numbers and negative natural numbers with 0 is called integers. In this way, I think that you will be able and you will be think so clear to understand integers, rational numbers. Then let's see what is rational number. A rational number is a number which is in the form of p by q. Rational number is a number which can be written in the form of p by q, where p is integer and q is also integer. Both are integers, but there is a condition for q. It means that condition for denominator. Q can never be equal to 0. Students, if q becomes 0, then whole number becomes infinity, and infinity has no clear definition in mathematics. That's why p, the number which is in the form of p by q, where p and q are integers but q is not equal to 0, is called rational number. For example, I can write here 3 by upon 7 minus 2 upon 5, 1 upon 3, 2, 1, 2, 3, 0. These all are examples of rational numbers. In first example, 3 upon 7, 3 is also rational number and 7 is also, 3 is also integer and 7 is also integer. In the second example, minus 2 is also integer and 3 is also integer. It means that p and q both are integers. In third example, 1 is also integer, 3 is also integer, and this is also rational number. But for 1, if I have written nothing at the place of q, then at the place of q we can consider. Also for 2, I have not written in the form of p by q, but it is clear that at the place of q there will be 1. And in 3, at the place of q there is 1. In this way, we observe that these numbers are also in the form of q, where at the place of q is equal to 1. Therefore, these 3 numbers can also be regarded as rational numbers. But students, for 0, what can you say about 0? 0 is also rational number, because whenever 0 is divided by any number, it gives 0. Then it can also be called rational number by putting here 1 or 2 or 3. It can take place only 0. That's why this is also a rational number. In this way, we have seen the definition of rational number, and also how can we consider that which numbers are rational and which are not rational. These all are the examples of rational numbers. After getting clear concept of rational number, let's see some laws from rational numbers on the basis of class 8. That is commutative law, associative law, distributive law, existence of additive inverse, and existence of additive identity. These are the law of rational numbers, and let's see here. Then, first of all, commutative law. Some important law. First is commutative law. Second is associative law. Third is existence of additive inverse. And fourth is existence of additive identity. Dear students, in the example of commutative law, we can write here a plus b is equal to b plus a. If we take rational numbers, then we can write here a by b plus c by d is equal to c by d plus a by d. For rational number, this example can be written. It means that there is only changes in the place of given rational numbers. Here a by b and c by d. First of all a by b and then secondly c by d. But equal to c by d and plus a by b, there is only change in the place of the given rational numbers. Hence a commutative law. If there is an example of this type, then they are considered as commutative law. But now associative law. In associative law, there are three terms. Suppose that a by b is a number and c by d is another rational number. Again e by f is other rational number, and this is equal to a upon b plus c upon d plus e upon f. If this type of example comes to associative law, then existence of additive inverse, very interesting thing. Existence of additive inverse, try to understand it. The number which is added to a given rational number makes the result as 0. That is called existence of additive inverse. For example, if I write here a rational number a upon b plus x, which gives the result 0. then x will be called existence of additive inverse, and value of x will be minus a upon b. That's why for existence of additive inverse, we can boldly say that the number when which is added to a given rational number, then it gives the result as 0, then that number, that is x, is called additive inverse of a by b, and its value will be minus x is equal to minus a. Now, student, existence of additive identity. Additive identity. Suppose that I have written here a rational number a upon b. Then I have added here a number x, which gives the same result a upon b. In this case, x is called existence of additive identity, and we can now define it in the following way. The number when which is added to a rational number, then it gives the same result, then that number is called additive identity of the given rational number. Now we can write here x is equal to a upon b minus a upon b, which is equal to 0. Hence, additive inverse of rational number a upon b will be equal to 0. In this way, all the four laws will be applicable in solving some questions from exercise 1A to 1G from your book.